Okay guys, so here is like a guide video. So what you want to do is pause the video, like use it to get you started and then pause and then try on your own and then, keep going, but just use it as a guide. Don't just like passively watch it. Okay, so consider the differential equation right there. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 0 equals 1. The function f is defined for all real numbers. A portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. All right, so imagine you're dropped into a storm system at that point 0, 1. Okay, to the left and the right, where is the storm going to take you? So to the right, it looks like we'd be going like that. Okay, and then to the left, looks like it's taking us down and then turning around and going like that. Okay, so 0, 1. I start there. And then we're going like, so just follow the pattern all the way to the end, to the ends. Okay, so we just did that first part. Now, the second part, B. Write an equation for the line tangent to the solution curve in part A at the point 0, 1. Use the equation to approximate f of 0.2. Okay, so you need to know this formula. Y equals, okay, f of A plus f prime of A x minus A. And in this case, we're doing f of 0. So this is telling us here that f of 0 is 1. So f of 0 plus f prime of 0 x minus 0. So y is f of 0 is 1 plus f prime of 0 I've got to find. So dy dx evaluated at the point 0, 1 is 3 minus 1 cosine of 0, 2 times 1. So 2 and then just x. So y equals 1 plus 2x. Okay, so there's the equation of the tangent line. Now we've got to use the equation to approximate f of 0.2. So now I'm going to look at this tangent line as a linear approximation, 1 plus 2x. So L of 0.2 is 1 plus 2. 0.2 is 2/10. So this is 1 plus, that's going to be 2/5. So 5/5 plus 2/5 is 7/5. So I'll just say to my reader very clearly, f of 0.2 approximately 7/5. Okay, that's part B. Now part C, find y equals f of x, the particular solution to the differential equation with initial condition f of 0 equals 1. So for part C, I'm going to bring down this differential equation. I've got to separate the variables. So I want the y's over here, the x's over there. So, and do this more slowly if you need to, but so I'm going to be dividing both sides by that and then multiplying both sides by dx. Okay, now we got to take the antiderivative of both sides. How do you do the antiderivative of this? Well, try f prime over f. So I'm going to let f be 3 minus y. So then f prime is negative 1. No, just negative 1. is negative 1. So I need the top to be a negative 1. So I just multiply by negative 1 over negative 1, and then you just take like the, 1 over negative 1 you take out front, but that's just negative 1. So basically just double negative. And then I bring down this negative, natural log absolute value of 3 minus y, equals antiderivative of cosine is sine plus c. Now we've got to find c. So you're going to use the initial condition. I'll section that off. Okay, so if we know f of 0 is 1, all right, that means that we got this point here. Okay, now I got to plug into this up here. So this is negative natural log absolute value of 2 equals sine of 0 plus c. So sine of 0 is just 0. So c is negative natural log of 2. You don't need the absolute values because it's positive. 2 is already positive. So it's the same with or without the absolute value. So now I'm going to plug that back in. Negative natural log absolute value of 3 minus y is sine of x minus natural log of 2. Now I got to solve for y. So you're going to put a base of e on both sides to cancel the natural log, but first I've got to get rid of this negative. So I'm just going to, divide every term by a negative 1. 3 minus y equals negative sine of x plus natural log of 2. Okay. Let me put a base of e on both sides. All right, so that's canceling. We have absolute value of 3 minus y equals e to the negative sine of x plus natural log of 2. Now, in order to solve for y, I need to drop the absolute values. So you do that by considering plus or minus. So the input of the absolute value could be plus e to the negative sine of x plus natural log of 2, or the minus 1. Now you need to use the initial condition to figure out which one it is. So, all right, so let's try this one. 3 minus y equals, let's try the positive one, e to the sine of x plus natural log of 2. All right, so plugging in 0, 1 for x and y, we end up with 2 equals e. Sine of 0 is 0, so it's just e to the natural log of 2. And what do e and natural log do to each other? They cancel, so we get 2 equals 2. Check. So the positive one works. Let me make sure the negative one doesn't work, just because if they both work, then I've made a mistake. So 3 minus y equals negative e to the sine of x plus natural log of 2. So I'm plugging in 0, 1. And then so if I plug in 0, 1 for x and y, I get 2 equals negative e to the natural log of 2. Then I get 2 equals negative 2, not the case. All right, so I know that 3 minus y equals the positive 1. And then I add, and then I'm going to subtract 3. E to the negative sine of x plus natural log of 2 minus 3, and then divide both sides by negative 1. So y is negative e to the negative sine of x plus natural log of 2 minus 3. And guys, their solution is actually going to be -2 out front, but it's equivalent to ours. All right, it is completely equivalent to ours. Okay, there it is.